Hi everybody, thanks for joining. We're just having a technical issue at the moment. Just trying to wait for Alison. I think because, there we go. Because Alison's a new starter, I think the tech hadn't promoted you to a full panelist. Sorry about that, Alison, but here's she.
That's I was getting a bit nervous that everybody else had gone to a party and I wasn't invited.
I know, me too. I thought I was in the wrong room, but yeah, but we're both here and you're promoted to a panelist, which is great.
Oh, fantastic. Is everybody else here or is it just us two?
No, other people are here now. I've had to invite everybody in, which is completely fine. Everyone's used to this. So I don't know if you want to share your screen.
Yep, shall I crack on?
No, we'll just wait a few minutes, but if we just check the screen sharing's working.
Okay.
And I'll activate the captions for Natalie. Oh, that's brilliant. We can see that.
Fantastic.
Yep, so a bit of a different start, but just to everyone who's joined, we're just going to wait a couple of minutes for other people to join it, and we'll get started in a minute or so. My
heart is going.
I'm really sorry about that, Alison.
No, it's fine. It's fine. Obviously, if this presentation is now a disaster, it's all your fault.
Yeah, it's the tech. It's the tech. We should have a Zoom bingo so we can see which faults happen at each Zoom session. I think we've just hit one.
Oh, I should probably do a Zoom bingo for my talk actually as well. I should have done that.
Yeah, well, we haven't spoken whilst being muted yet, so that's normally number one.
I'm trying to think if I've got anything embarrassing open on my desktop to pop up inappropriately. That'll be number two. My children went back to school today, so the half-naked child wandering through demanding something's not going to happen, sadly.
Oh, that's always a fun one. When I was in a Zoom this morning and somebody's dog was sick, so.
Oh, nice. Oh, I haven't had that. I've had lots of cats walking across and then showing their bottom at the screen and then just carrying back on again.
And Stefano said nobody's getting hurt. So that's abusive agent-based models.
Is that Stefano? Ah, hello, Stefano. Well, don't know about that, Stefano. We'll see.
Okay, so I think we're a couple of minutes in, so I think we'll get started. So I think I'll first off start by thanking everybody for joining today's seminar, which is entitled Using Agent-Based Models to Simulate Social Systems by Professor Alison Heppenstall. So Alison has recently joined the university as a professor in geocomputation, and Alison's based between the School of Social and Political Sciences in COS, so the College of Social Sciences, and then the newly formed System Science and Public Health program here at SPHSU. So Alison has joined us from the University of Leeds, where she was in the Leeds Institute of Data Analytics, and is also a fellow of the Turing Institute. And her expertise is in AI and machine learning, agent-based models, big data, urban analytics, and uncertainty in simulation. So unfortunately, Alison's joined, but we can't yet meet her in person, hopefully very soon. But I really want to thank Alison for agreeing to deliver today's seminar so we can at least meet you virtually and hear about your research. So we're hoping for about 10 to 15 minutes at the end of the seminar Q&A, which would be great. So I'm now going to pass over to Alison for today's seminar.
Thank you so much, John. And apologies, people, for my arriving late. I like to make an entrance. This is a little unusual as well, because essentially I'm sat in my living room giving you a presentation. I can see there are 58 people here, but I'm going to be laughing at my own jokes and assuming you will be too. That introduction was great, and I'm going to skip over my first slide because that's kind of everything I was going to say. Hang on, my slides are going to work. That can be the second one that's going to break. So yes, I'm one of the newbies. I joined University of Glasgow last month. Now, if I was there in person, we'd hopefully meet and go for a coffee or go to the pub, and you'd find out a little bit about me as a person, not an academic. So I thought I'd start by telling you about me. So who am I? Well, some pictures here. I love wearing bright red jackets trimmed with gold on them and big gold buttons. So I'm in a brass band. I play a musical instrument. During lockdown, I thought I should get healthier and fitter. I'll do a triathlon and join the local triathlon club. Brilliant idea on paper. So my triathlon club, Leeds and Bradford, has the Brownlee brothers, a couple of Olympians in and world champions in. I'm a really keen paddleboarder. I love all sorts of water sports. I'm actually deaf, so I do sign language as well, but perhaps the most important image on there is the whiskey. I'm a massive whiskey fan. Ardbeg Ugadal being my favourite. Okay, so that's kind of a bit about me as a person, as an academic research. So I did this word cloud this morning, and the words aren't in any particular importance of size, but these are all the sorts of keywords you would associate with types of work that I've done. So I would describe myself as a computational social scientist. My background is physics and computing. I worked in the geography department, as John said, for many years, and I'm really interested in developing models to help solve complex problems. In this case, a lot of spatial problems, hence the urban analytics, which I'll come on to. Now, what you will notice about this word cloud is an absence of one particular word, health. I am not a health expert. I've been recruited in for my 50% in the unit to sort of strengthen the program Petra's leading, which I'll come on to, and bring in some expertise within data science, computational modelling. What I'm really keen to do is to collaborate with people across the unit, and I've been starting to research the fantastic work that's going on to try and understand where the collaborations can be, where the area that I come from can be beneficial and vice versa. Some people collect stamps, some people collect football cards. I collect affiliations. I seem to have many affiliations. I'm split between two places in the university, and there's some of my affiliations there and many more. But in terms of this talk context, there's only one affiliation that really is important today, and that's the unit where I'm based. I still haven't quite sorted out the where I'm based and what I'm doing, but one of my hopes is that in both over in COS and over in the MRC unit, we're going to find synergies between the work in the sort of urban area and the health area. And I think there's a lot of overlap and great potential work we can do between the two parts. But I'm still sort of trying to work out who's doing what and where that all fits in. So again, anyone's got any ideas or excited about collaborations, I would love to hear and talk to you about that. What am I going to talk about? Well, this kind of is like a bit of a smorgasbord, a tapas bar of everything. I want you to go away and just sort of say, yes, that's Alison. She's loud, she talks quickly, has big hair, she does this type of modelling, and she'd be interested in this sort of work. And that would be great if that's what you take away. So I just kind of want to introduce you to the stuff I'm doing. I'm going to talk a lot about it, obviously, in context of urban, but I'm hoping to do it in a way that you can sort of see where the links could be between the health work that's going on in the unit and the sort of approaches that I bring as well. I'm also going to talk very briefly, give you a little teaser about a type of work that I'm hoping to do within the unit as well, and some of the challenges associated with that. And that links into work that I've currently got ongoing. And of course, I'm happy to answer any questions throughout. Okay, so kind of as the context of the work that I'm doing, this is Trafalgar Square from a few years ago. In the middle of the day, there's a bunch of people walking around. Who are they? What are they doing? Where are they going? Why? Now, from the perspective of urban analytics, these are really important questions that we'd like to understand. So we could look at questions, answering questions such as, if we to pedestrianise the centre of London, what's the impact on air pollution, therefore on health, therefore on the NHS, therefore on the cost of certain diseases? These quite complicated questions that have many parts and interdependencies as well. What we do have at the moment, so we have lots and lots of data, big data, which is a dreadful phase. But we have social data. People have sort of smartphones they carry on. We have mobile phone data. People check into places. We have sensor data, such as pollution sensors, footfall sensors. So we've got lots of information about the city. We've got lots of information about people, but we don't really have the skills and methods yet to bring these two together to really understand how people are moving around and using spaces in cities. We do, however, have all these sort of AI data science methods that are coming online. A lot of the machine learning methods have been banging around since the 80s, but more data, the better computational power are sort of really coming online, particularly deep learning neural nets. And we're starting to use these sort of techniques, mine out of the data, what's going on within cities. Can we pull out hidden processes, what's happening over space and time? And can we start putting all this data together using these methods to really understand what's going on? Now, that's kind of been the main sort of thrust of the work I've been doing for the last sort of 15 years. And I think that's something that readily can be extended and built upon with a health context, but I'll come back to that. As John mentioned, I am a Turing Fellow, so I have an ESRC-Turing Fellowship. And the idea behind this fellowship is to have somebody who works in the social sciences applying AI, data science methodologies into these types of problems. So my fellowship's kind of got a few parts to it. I've done quite a bit of work looking into data, linking data, trying to tease out how different patterns over space and time, hidden processes. So how do you know when a process is going to become important? So your system ticks along when a group of people become a crowd, become a riot. At what point do those flips in the system happen? How do they emerge over space and time? Geographers are brilliant at finding hotspots spatially, but we're not so good at working with time. So it's been a lot of work and currently within that area as well, looking at trying to understand patterns over space and time. Real-time simulations, I'll come back onto this, but creating models that run in real time and you update in real time so you can get really accurate short-term predictions. And this is emulating work that meteorologists do, the ensemble modeling forecasts. And then finally, it's sort of been designing and building large agent-based models, digital twins. And digital twin is quite a loaded phrase. In this context, a digital twin is trying to recreate a city, all its processes within a computer screen. So you can play around with interventions, see what happens if you pedestrianize, et cetera, et cetera. So it's a recreation of a physical city in your computer. I put this slide in just because I appreciate I'm talking to people working within health, but I thought it would be useful for you to understand why this problem is so difficult and requires the techniques. And I think, again, there are synergies here and hopefully things that you pick up on that are relevant as well. Urban environments, difficult to model space. Space is such a pain to have to model. So I'm a computational spatial scientist in that the models I build embed space in implicitly and explicitly. I take account of what happens over space and time. There's one rule in geography, Tobel's rule. Near things are closely related, the further apart they get, more different. You could argue that this is come largely defunct as the world's become more connected and mobile phones, et cetera, et cetera. But essentially, processes will change over space and time. How do we account for that? How do we grasp that and put that into our models and reflect that? Human behavior, that's something I'm going to come back to several times. So in lectures, in the olden days when I gave lectures, I say to students, pick a number between 1 and 4. So if everybody does that now, obviously if we're in the same place, I'd then get you to put your hands up. But my prediction is the majority of you will pick number 3. And then the second majority will pick 2, and then other people will pick 1 and 4. And this very simple experiment tells us that some behaviors are quite predictable and we can put into a model. So pre-COVID, we could build models of journey to work. We knew working population leave home, take some sort of transportation to a workplace, go out for lunch, come back, go home. Add in multi-purpose trips, shopping, picking up kids, etc. A lot of the behavior we demonstrate is fairly routine. Now that Trafalgar Square I showed you at the beginning, those people are tourists, vagrants, who knows? It's the middle of the day, why aren't they at work? We don't know about that type of population. And there's lots of other populations where we have bits of data about, but we don't really understand and need to be able to understand what they're doing and their behaviors and how they're going to play out over time. And that's kind of pushes towards thinking about cities, urban systems, or any system involving humans from the individual perspective. Previously, we would go top down, we'd apply a model or rule at the top level, apply it to everybody, but increased data, understanding, we've now shifted to the bottom up perspective. So there's a real sort of drive within the social sciences of saying that it's the individual that shapes the processes within social systems. Really, the decisions we make drive all the processes. Mike Batty, who is essentially like the godfather, looks like a godfather within this area, takes it a little bit further within urban context, saying that cities are shaped by individuals who are linked have networks between them, and between these networks flows information, goods, money, etc. And that's what shapes and drives our cities. So this really brings together complexity, system science together. We have to capture, if we're going to model these cities, the individual, but also all the processes that are going on around them as well. And that kind of leads me to the sort of technique that I play around with predominantly. This I stole from a colleague of mine many years ago. So this is from Sims back in the early 2000s. And this really nicely illustrates what an agent-based model is for those who don't know. I realise probably Stefano, Eric and Rich are on the call and they can sit back at this point. An agent-based model is individuals you create. So sort of in the bottom right-hand corner, you create an individual, you give them characteristics based on census variables, survey data, whatever you have. You create your individuals, you put them in an environment, give them some rules, send them off and see what emerges. And that in a nutshell is the idea. Now, how complex these models are really depends on the questions that you're asking and what you want to get out. But that in a nutshell is an agent-based model. Mr. Clippy there, somewhat showing my age, is noted as the very first intelligent agent. He would appear when you were writing Word and annoy the crap out of you. I believe he's come back in some forms as well in Word as well. But he's an example of an intelligent agent that reacts. To give you some examples, and again, this is within the urban area again, of the type of timescales and spatial scales these models are applied to. They're pretty much everywhere. In fact, this is from 2019, this image, if I had redrawn this week, it would just be COVID, 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 COVID everywhere. Dreadful COVID models, but it would be full of COVID. Majority of these models we see now are at the micro level. So individuals, small geographical areas, streets, neighborhoods, over at minutes to hours. But of course, you can see from the diagram going up to the very top right, people are trying to use them for things like migration, but at that point, spatial interaction models, other types of methodologies become more relevant. There's a massive spread of applications of these models. In fact, I did a talk last year at ESSA, or was it earlier this year? It's kind of all blurred into one, and I've coined and patented Heppenstall's law, which means that when a technique, a concept, whatever hits mainstream, lots of these navel-gazing articles suddenly appear about it. And as you can see, I'm kind of guilty of that as well. And that's what's happened with agent-based modeling within both social sciences and the spatial sciences. These models are very much accepted now and sort of part of the researcher's toolbox. It's interesting to note in a depressing way, there's an article here by Andrew Crooks from 2008. It's a really excellent article that lists out all the challenges that agent-based modeling had at that time. I joined the bandwagon early this year and published an article, and basically those challenges still haven't been met from 2008. Progress is being made, but for some reasons there's still a lot of challenges to go on. And I'm going to pick back up on those towards the end of the talk, because I think some of these challenges have relevance to some of the modeling work that is occurring in the unit as well. This is my rant slide, but I'm going to spare you it. This is one to ask me about in the pub. I did another keynote, and I was trying to reflect on the types of models that are prevalent. But if you hadn't heard of agent-based modeling prior to March 2020, you most certainly have now, even if just in a sort of notional format. The models that Imperial derived, Neil Ferguson, were individual-based models that informed us going into the first lockdown. And there's a really nice article actually from Washington Post that sort of explained how diseases spread and used a very simple example from a program called NetLogo, which is a framework to make these models in, and sort of really set alight people's imaginations about how these models can be used. If you go to Google Scholar and type in agent-based model COVID, 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 95% of which are dreadful for reasons I will come back to, so you haven't fully escaped the rant. The point of this is that these models really are everywhere now. And I think while the applications within the health arena, there are some areas where I have seen them in active health and travel, these models still aren't fully utilized within health, which is surprising because hopefully you can see there's analogies between the work I've done in the urban setting and what can be done within a health setting as well. I'm going to give you a couple of examples of how we can use these models. And again, I'm not going into mass amount of technical detail. I'm really happy to have a geek session with anyone who wants it afterwards. This one's quite nice because it also shows you that you should talk to people. I mean, as a data scientist, computer scientist, that's kind of a terrifying idea. But this is work my colleague Nick Alison at Leeds performed, and I got involved with, I'll explain why. And the idea here is that can we use all these data sources that I talked about with Trafalgar Square, all these lovely data sources, to put them together and actually work out how people move around a small town. This is not a great illustration. The town is here. And in fact, this is a town I live in, and I live just about there. That's where I'm talking to you now. And so we use a census, created a population. We had some survey data, work time survey, put that in. What was really nice about this at that time, there were a lot of sensors put up around the town centre. So we also had excellent footfall data. So we knew how many people were in the town at different times of day. We didn't know who those people were or where they're going or why, you know, there's other parts of the questions, but we thought we could fill that in by creating a model using these different types of data. So we created, used population synthesis, created our population, turned them into agents, gave them some rules, put them in houses, and off they went. And we sat back to wait for fantastic results. Nah. What we got was this. So the thick black line is the real data. And the line I want you to look at first is the dotted one. So around about 10 o'clock and then around about lunchtime are the biggest disparities between the output and the real data. And we kind of stumped our heads, but we've looked at the data, we've mined the data, what are we missing? And I said, this is performed in the town that I live in, and there's a science cafe that used to run pre-COVID. So I went and presented this at the science cafe. So, you know, went and talked to people. And it turns out we're missing two populations in here because we've just used the data and not embraced anything qualitative. At 10 o'clock, it appears that everyone's gone to work and school. The retired population come out, go off, do their shopping and go to the coffee shops. And that's who's predominantly in the town at that point. The surveys we had did not pick that up. The other population we're missing around lunchtime is the school population. There's a high school quite close to the centre of the town, and year 10 upwards are allowed out to go buy their lunch in town. So again, we weren't capturing that. So we put that data in, those dynamics and reran it, and then we got the sort of hash line, which reflects the real data much better. So, a really important lesson learned here. I can have all these data sets in the world, these great quantitative data sets, but actually it needs a combination of qualitative data, quantitative data, and to go and talk to people as well. So hard lesson for a computer scientist. Okay, behavior. How difficult can it be to model how somebody moves and behaves? Well, apparently it's very difficult. I should say that no agent-based modeler is attempting to model a full swathe of human behavior. That would just be sheer madness. Often we're interested in a very sort of narrow spectrum of behavior and simulating that. However, it's still incredibly difficult. Creating a model where I've just shown you there, where we can capture the routine behavior and tweak around with that on the basis of other knowledge is fine, and that works very well for that application. But if you're interested in something to capture that daytime population, we don't know what they're doing, or certain groups or more extreme behaviors that we perhaps don't capture in the data, then it becomes incredibly difficult. If you're trying to understand how people are going to make a decision now based on their knowledge and based on circumstances that are happening to them, based on socioeconomic characteristics, health, etc., that's incredibly difficult because you need to capture all the causal effects in there. You need to build in a suitably complex behavioral framework and have the right sort of data. So depending on the perspective and the detail you want, behavior is incredibly difficult to get hold of. This is some work I did with Nick Alison a few years ago, and the aim here was to simulate the behavior of burglars. This was work done in conjunction with a partner, West Yorkshire Police. And they had a lot of data about the motivation of burglars and where these crimes occurred within Leeds. And at the time, next to Leeds University, there's a place called Headingley, and that's where the students live. And there's a street there that I think still is the most burgled in the UK. Big houses, lots of students and goodies in there. So we were very much motivated by understanding the patterns of this and how we could develop a tool and help the police to sort of target harden and understand where the crimes are happening. Didn't quite go down that way. What we did do is sort of build a model to represent the behavior of the burglars, and we used something called the PECS model. I think that's physical, I can't quite remember, physical, emotional, cognitive, and social. It takes account of different needs and wants that a person has. And in this case, crudely putting it, if a burglar wanted drugs, they would want to go and commit a crime to get the money. Very simply put, that's kind of how it would work. So we did this, and we had talked to burglars, or the police gave us data, but the data, I should say, was from burglars who've been caught, so possibly not very good burglars. And we built all this into the model and worked with the police and the experts. Now this, again, you'll see, it's just a bit of a illustration. This is Leeds. The red dots are burglars. It will zoom in a moment and you'll see them going into a house and burgling. So this essentially is what the model did. As this simulation ran, the burglars were able to build up a cognitive map of the area and the history, and would know, actually, if I go over there, that's a big hall. So that's sort of information we built in as well. Now we use this with the police. At the time we did this, there's a part of Leeds that was being regenerated, and the police wanted to know, we regenerate this area so we can make the houses more secure. Where's the crime going to displace? So one of the nice things about this is that we successfully predicted where crime was most likely to displace, and that kind of helped the police in sort of target hardening the areas. And of course, I assume the crime then displaced onwards as well. But in terms of building a model, working with a stakeholder and capturing reasonably well behavior, that this model was really good. But again, we were looking at quite a focused type of behavior. Let's have a drink. So I thought I should put a health example in, and you might guess I couldn't bear to put any horrific COVID examples in. I'm also a journal editor, so if I see another COVID ABM, I possibly might explode. So what I've given you instead is an example, I think quite a nice underdeveloped example of an agent-based model being applied to a health application. In this case, it's the work of Andrew Crooks, who's out at Buffalo, and he looked at refugee camps and the spread of cholera. What he did was he created a simple model. People would have goals, they'd have a home location, they'd have things to do in the daytime, the parameters down the side were important parameters of how they built up the rule set. So these all form parts of somebody's day. Put this together, worked with the partner to get data to sort of validate the different behaviors that were going into this, and then embedded a very simple epidemiological model. And we probably all, well, you're a health unit, so I'm guessing you'll laugh at the simplicity of this, but this type of model was embedded within the ABM as well. And what they did is they took different sites, they took a real count of the geography, and the different blue dots in there are water sources, and a triangle is an infected one. They looked at where the infected water was, and therefore how the infections would spread spatially and temporally. And they had data where they could validate this again. So I quite like it because it's quite simple, but it was well validated. What I also like about this, well, actually, the downside, I should say, to this is that there's no network of knowledge. So if somebody gets infected, that knowledge isn't passed on. And you'd assume by day 9, people will be fairly au fait with where the infected water was. So there's no sort of knowledge spreading throughout that. But again, it's quite a nice example of what you can do with a model. Okay, so all the examples I've given you so far really rely on one thing, lots and lots of data. Not just any old data, but really sort of rich individual level data. And this is not just an agent-based modeling issue. This is across any modeling technique. The better the data, the better results. The old garbage in, garbage out. One of the things, I think one of the downsides possibly of agent-based modeling and why they're so poorly validated and not used by policymakers as much is because of a lack of data and therefore a lack of getting to grips with validation. How do we know that lovely model we put together and those results actually are what are happening out in the real world? And that's a big area to work on, and an area where we need better data. There are kind of a few ways to get around this. And one of the ways is certainly in agent-based modeling, population synthesis. So I want to model a population doing something. There's a technique, population synthesis, also known as microsimulation, where you can take data, often the census, you're adding some survey data or what other data you have that pertains to your particular population, and generate your population and situate it geographically as well. And that's something that we do quite a lot of, and it's fairly well-known techniques for that. However, I say, what if we can't get hold of the good stuff? What do I mean by that? Who here has had a project, so a 3-year project that relied on, and you got your letter of support saying you could have access to that secure data and you could have it straight away. 2.5 years into your project, you still don't have the data. And this sort of frustration of this has kind of emerged this project that I'm doing with the Turing called Quip. And the idea here is, what if we could generate synthetic versions of these secure data sets, health data sets, finance data sets, that contain within them all the cross tabulations, so all these relationships that we're interested in, but can preserve the privacy of the individuals. And this project is just entering its second phase, where we're now working with a couple of London hospitals, looking at patient records, synthesizing those and testing the methods we've been playing around with to see if we can do just that. Can we produce a synthetic version of that really sensitive data set that keeps everyone's privacy intact, but has enough utility for it to be useful to us? So that, to me, is that one of the more exciting things that's going on at the moment, and will be absolutely fantastic if we can get some case studies showing that's successful and other organizations come on board with that. We're talking to ONS about this as well. There's details there on that. To give you a more sort of operational example of population synthesis, you'll have heard of the CIPHER Consortium. Petra and Karina are both directors within the unit, and I'm one of the co-Is on this. And unsurprisingly, I'm like co-lead on data and micromodeling. And this here is a paper we've just put into Nature Scientific Data. And it just shows you, I just want to give you a bit of a flavor of, this is population synthesis operationalized within CIPHER. So here's some of the data down one side that we've been playing around with. And on the other side, I know the maps are quite tiny, but there's Glasgow in there as well. I haven't yet worked out where the university is on it. I'm not a very good geographer, but that shows you the sort of different types of things we can pull out. So we can create a population, we can map it spatially, we can validate it, and we can start doing things with that population as well. What sort of things? Well, I have a PhD student, Rob Clay, who is amazing, and he's played around with dynamic microsimulation models. So this is the idea: you create your population and you want to see how something evolves over time. If you apply transitions to each person in the population over a period of time, what's going to happen? Now, this is really difficult to do because you need to build something called transition probabilities. And that's a probability for me. What's the probability? I'm going to move, I'm going to get a year older, I'm going to get married, I'm going to develop mental health problems, etc., etc. And Rob is doing this by looking at trying to develop better ways to handle these transition probabilities. Looking at mental health and employment. And the ultimate aim of a PhD is, can we develop a tool looking at this that we can hand to policymakers that they can play around with as well? It's a really exciting work going on there. Okay, I'm getting towards the end now, but I just wanted to kind of pull it back to Glasgow and why I'm now in Glasgow. So a lot of the work I've been sort of immersed in at Leeds and at the Turing is creating this idea of urban digital twins. Can we collect the data? Can we model how individuals move around cities? Can we understand how cities are living, breathing, to use a Mike Batty phrase? And if we can, you know, urban planners, governments, etc., we can improve cities for people, you know, make them more sustainable, more equitable, etc., etc. So, you know, the big pie in the sky idea is, can we take that idea of creating digital twins, but actually apply it to health systems? Can we capture all the different factors that are going on within a health system? Notice I'm not giving any examples here because I'll trip myself up. But, you know, can we link the different processes together from health, housing, environment, the economy, to really understand perhaps how the production of inequalities are coming out? I'm told never to say the Glasgow effect, because that's a bad term. But, you know, I'm going to move to Glasgow. I'm going to get fatter and die younger. So I'm kind of interested in that. But something like that, could we simulate within a digital twin all the effects of, you know, the Glasgow effect and try and understand all of that? That's kind of like the pie in the sky idea. I'm not doing this work alone. So as mentioned by John right at the beginning, so there's me at the beginning of a school holidays looking rested. This is me on the first day my children are back in school. So there's me, and I'm bringing in computational modelling expertise. I'm also joined by Petra and Karina, who will be doing a talk in a couple of weeks as well. So both Karina and I both come from an individual-based modelling perspective. Karina has different expertise to me. But together, it's quite a complementary team with Petrus bringing in some health magic as well. And we're going to be working together and meeting for the first time in person next week to try and evolve these ideas and really sort of flesh them out and sort of understand the type of work we're going to be doing. So you're going to hear more about this, and undoubtedly I'm going to be wanting to talk to loads of people within the unit about different aspects of this work as well. But I mean, to me, the idea of creating a digital twin of health something is incredibly exciting, but there's a lot of challenges with this. And from my perspective, the computational side, behavior, how do we represent that? I already talked about that. Validation. One of the biggest bugbears I have, apart from COVID models, is validation. Agent-based models, black art, barely. It's for various reasons. So we need to get past that. How do we handle uncertainty? There's uncertainty in the data, there's uncertainty in the parameters and the rules that we build. When we run models, there are uncertainties that are carried through that. How do we capture, quantify, and communicate those over to policymakers? So we create a model, we run an intervention, whatever, and we can then say, I'm 80% sure in these circumstances, this is what's going to happen. That's not done really at all within agent-based modelling, and it's something that needs to happen, particularly if we want to engage more with stakeholders and have these models really sort of taken out of academia. Complex results, agent-based models, you can rapidly build a fantastically complicated model, but we don't really quite have the tools yet to understand the results of this over space and time. So, you know, that idea of your system goes along and flips from one state to another, that noise becomes suddenly a very important process. We're not so great at picking those out. Some machine learning techniques are starting to help with that, but that's still a big area. And model abstraction. You're going to want to scale these models up. You might just say create a digital twin of Glasgow, but you want to scale up to Scotland. You know, how do you abstract? What are the processes? If you're modeling at a small scale, what processes do you abstract up to a city scale? You know, these are really challenging issues to sort of get our heads around. I'm not a health person, so no one shout at me for this. So, and these, I think, from listening in, are some of the issues from the health side as well. Interdependencies seems to be a bit of a challenge between cause and effects. Direction sizes, causal inference modeling could be where Bayesian modeling, probabilistic programming. Individuals, I've already covered, are a bit of a pain to model, but I assume that these interdependencies make individuals, embedding those within individuals and their behaviors is challenging as well. I've already kind of talked about the last one, model outputs to policy, I've kind of mentioned as well. Uncertainty, again, you know, there's a couple of things, you notice there's several here that overlap with the challenges I have as well. But again, uncertainty, how do we do this? My last few slides, I'm getting there, are really about just a couple of those challenges and some of the work that I have ongoing with the Turing and still with colleagues at Leeds as well. And I'm mentioning these because I think some of this work could be of interest to people within the unit as well. So data simulation, this is the idea that you have a model simulation, you have your output, and as you start your model simulation, this is your real data is here, but your model output goes here. And there's quite a difference between the two. If you add in data, they'll snap back together and you'll have an accurate short-term prediction. So we're trying to, we have a big project down at Leeds and the Turing and now Glasgow, where we're trying to create processes for putting data into agent-based models in real time. So you have your model of a city, something happens, I don't know, the train station blows up, immediately data comes in about that, you can input it into your model and you can get very short-term, like minutes to hours, predictions out of it. Sounds nice and easy, doesn't it? Really. One day I'm going to pick an easy application to work on. It's not. We've been looking at sort of methods from physics, sort of mathematics to do this. This is a very simple abstraction of a train station. People come in one end, people come out the other. That's as complex as we've got this so far. And we've been playing around with sort of like Kalman filters, ensemble modeling techniques to be able to do this. There's a couple of papers there if you're interested in this, but this is an area that I think is almost, after you've solved some of the other issues with behavior and validation, getting your data in real time and moving your models along is where we need to be moving towards. Uncertainty. I have a postdoc with the Turing who's working on this, and we have a project, and it's just all about uncertainty quantification for agent-based models. I'm going to give you the really sort of simplistic overview here. There is a paper just about to come out in JAS, which I'm happy to send to people or chat about this. But essentially, we've taken history matching, which is used over in sort of physical sciences, to sort of shrink down the parameter space for space that's plausible, kind of a bit like optimization, sort of not, and then applied approximate Bayesian calibration to sort of look where the most likely places for our values to be. And that's kind of a really crude way of putting it. But by doing this method, we can quantify the certainty and thus the uncertainty within our parameter values and our model outputs. I realize there's quite a bit of a leap there from what I've just said to that final sentence, but really happy to, this is really exciting work. So I'm very happy to have a chat about this sort of work and how we can try and apply it into ABMs that are applied within the health area as well. I think this is a really important area if we're going to get these models out to policymakers and convince them what we're saying with these models actually is beneficial to them as well. And so kind of one of the final ones I'm going to talk about is going back to that behaviour as well. So I've stolen a couple of slides from my colleague, ex-colleague, Ed Manley. And we've got a postdoc and a student working on reinforcement learning. And this is an approach from AI to let the agents, when you set up your agents in an environment, instead of giving them the behaviour, which is usually from historical data with events and you train your agents, you actually just put them in there and you let them go learn behaviours in whatever environment they're in. And the idea here is that instead of immediately constraining your agents by using historical data to inform what they're doing, they can go learn the behaviour, and therefore new behaviours that you might be interested in can emerge. It's kind of still in its infancy, and it's been used a lot in conjunction with Unity, which is a big computer environment platform which generates 3D cities. So you imagine you have these 3D cities, and you put your little agents in. But here is a very, very simple example. One is trained. When they do what's right, they're given a reward. And the one on the right, it looks like me trying to go find my coffee machine first thing in the morning. Again, this is an area that's rapidly emerging with agent-based modeling, new ways to sort of get past this behavior problem as well. And this brings me on to sort of my last slide. And I kind of wondered how to conclude. I appreciate I've kind of thrown a whole sort of range of little bits and pieces at you. But really, I just wanted to sort of say hello and sort of show a different range of work that I'm doing. It's kind of difficult doing this over Zoom and not being able to see anyone of them myself. But I think if you go away and, knowing that I work within the computational models, I'm interested in anything, which is a bit of a curse. I'm particularly interested in any collaborations, applications involving individual-based models, network models. That's the sort of thing I'm interested in. I'd like to learn more about what's going on in the unit in this area as well. Next week, I'm in Glasgow. I'm so excited. I'm picking up my staff card. I'm going to Berkeley Square. My desk booked out. So next Wednesday, I will be at my desk, wherever it is, all day. So if anyone's there and wants to come and say hello, please do. I'd be delighted just to talk to somebody in real life. Other than that, that's me done. And we've got, I think, a bit of time for me to field any questions.
We do. Thank you, Alison. That was a fantastic seminar. And as you say, it must be weird to just be speaking to yourself in your living room, but it was fantastic.
Well, when my kids are here, they don't listen to me, so it's no different to usual.
Yeah, but I think we're really lucky that you've joined the university, and I really enjoyed seeing the examples of the models you've been working on.
Oh, thank you.
And their real world application. So as you say, we do have some time for questions. So people can ask questions by either raising their hand and I can unmute you, or please add your question to the chat and I'll read it out. So we've got a question from Rich Mitchell. I know you've already met. So Rich, I've allowed you to talk, so please fire away.
Thanks, Alison. Can you hear me, guys? Yeah,
I can.
Great, great talk, Alison. Really exciting and inspiring, and so interesting to see the kinds of things you've done. So I've got a slightly awkward question for you, I guess, which is that I guess in my world, often the situation is that we don't have data with a lot of granularity in space and time, and often we don't really. We maybe have ideas about how and why people behave. But in order to code the decisions the agents make, we're kind of missing that. And I wondered if you'd like to reflect on the possibilities of ABMs in those kind of sparse data, maybe only theory type situations. That doesn't seem to be your bag, but I wondered if you might be persuaded to help us in some of those sorts of situations.
Yeah, it's Karina who's talking in 2 weeks. No, sorry, Karina. Yeah, I mean, I think it depends. I mean, maybe agent-based models in that situation isn't what you're after. I mean, there are lots of examples. And one of the things I should say about agent-based models, I've emphasized that they're very data hungry, but you can build a model with sparse data, with assumptions built in. You can embed qualitative data into it as well. I mean, I guess without knowing what your application is, and that, I would say I would usually look around for secondary data sources, substitute data sources, but then of course you've got the issue of, are you capturing the right processes out of there as well? And how do you validate that? I mean, there's so much data around now. I wouldn't say I'd be surprised if that was the case, but I think there are solutions to get around that with either synthesizing data or building more abstract models and trying to persuade people to give you the data. But you're right. I mean, that sort of missing data type thing isn't sort of my bag, really.
I guess I think there's a lot of data around which kind of tell you like the parameters of the system and generally what happens, and to some extent data on how individuals, what they do, but not always why. And I suppose my experience of my limited experience of ABM so far is that that's the really hard bit.
Yes, absolutely. And that's, you've sort of encapsulated one of the headaches that we've had in the urban environment. That's exactly that. We can usually know pretty much, with footfall data, where people are in a city, but we don't know who those people are, what they're doing there. But then we can have mobile phone data, which tells us how people are moving around a city. But again, we don't know who they are, their socio-demographic characteristics. But then we can get social media data that tells us a lot about a person, but actually doesn't tell us the other things as well. And I don't think there's, this is one of the sort of challenges I was alluding to, that we have all this data now, but bringing all those elements together in exactly the way you suggested would be fantastic if there are methods, but it's one of the big challenges of sort of harmonizing these data sets so we can sort of have who, what, why, where they're going as well. And that's I think work is being done within that in different areas, but there isn't a clear answer to that yet.
Okay.
But surely people in health, you've got loads of data, haven't you?
Yeah, but not always the data we want. Anyway, thanks. It was a great talk, and I'll shut up now and let someone else.
Thanks, Rich. Nice to talk to you.
Thank you.
Thanks, Rich. If anyone else would like to ask a question, please just raise your hand or add something.
I'm disappointed no one's asked what brass instrument I play.
What do you play, Alison?
The big one, tuba.
Oh, wow. I think there's a couple of people who are in bands as well. There's quite diverse, and there's a few athletes as well. So,
I'm not an athlete. I might be doing triathlon training, but I'm not an athlete.
Okay, I'll ask. Peter Craig has raised his hand. So, Peter, I'm going to unmute you. So please, you should be able to talk now.
Okay, thanks, John. That was actually a bit of a slip of the cursor. I was actually trying to add something to the chat, but never mind. I'll dig down my point. Anyway, there's a really interesting exchange between Andy Baxter and Stefano right at the top of the chat. And Andy pointed out that there were a lot of people getting run over in your animation that you had on your first slide, Alison. And Stefano points out that well, that's the beauty of simulation. You can just allow people to be run over and nobody gets hurt. But is it actually a strength of the modelling, or does it also imply a weakness in the sense that you can allow all these arbitrary events to happen, and unless you can attach kind of estimates of the cost and the consequences of those events that you're allowing to happen, then the model is kind of to abstracted from reality to actually provide predictions that are useful for decision making, and can you get to the point of usefulness without the complexity becoming overwhelming? That's my question.
Yeah, no, that's a great question. And that animation at the beginning, you're right, there are, it's from SimCity, there are things running into each other and people being killed. That is, I think, one of the not people being killed being an advantage, but if you create a digital twin, you are creating an artificial laboratory on your computer. So if it's really accurate and robust, which is sort of the second part I'll answer in a moment, I could restart COVID through and look at how we could actually do a proper lockdown. Not saying that in England we haven't been fairly treated, by our government. But it's a laboratory, so you can do things that aren't ethical in there. You can infect all the kids, all the things that you can't do. So in one respect, yes, being able to run people over if you are testing AVs within a simulation environment, you've got a certain moral flexibility maybe that you don't. However, bring it back to what you said, that's interesting to a point in perhaps the things you want to test, but how do you validate these models? So it's then taking that artificial laboratory and then transferring it into the real world. And that's where, kind of part of Richard's question was as well. That's where we're kind of falling down because of data and lack of really good data and validating and understanding what's going on in that system and getting to a grip to that complexity. But that's also one of the things that, Petra, Karina and I are going to be hopefully tackling within a health environment as well. So it's going to happen.
Thanks very much.
Oh, who's my brass band? I play for Otley Brass Band, and I occasionally guest for Grindthorpe and Black Dyke, and I also have lost my hearing from playing brass as well. That was a question I just saw.
Yeah, I saw that from Natalie. Natalie's a statistician in the team and used to play in a band. I'm going to allow Vital. Vital's kind.
Hi, Alison.
Hi,
so I'm going to ask a slightly naive and potentially kind of naughty question. There's been a lot of debate about the distinction between microsimulation and ABMs, and I wondered what your take was on what the kind of distinction is between them.
Oh, you're prodding me. You know this, Vital. I bet you're grinning right now. Okay, so I'm an agent-based modeler, so I would say that's the superior technique to use. However, I appreciate there are people on this call who are screaming at me now. The difference, there's so much overlap between them now, actually, that it's becoming largely semantics. If you want a distinction, with agent-based models, you have rules and your individuals interact and exchange information money. In a microsimulation model, the individuals don't interact. You apply those transition probabilities to each individual and run it through time. Computationally, microsimulation models are easier, and they're also easier to validate as well, where agent-based models are all about emergence and complexity. So what you would apply them to are very, in my mind, quite different. There are some clear microsimulation applications: population synthesis, static dynamic microsimulation, impact of putting closing an industry, etc., on a population. You wouldn't do that with an agent-based model. With an agent-based model, you're interested in behavior of individuals and how that changes over time with an intervention affecting it. And that was a naughty question, Vital. Obviously, agent-based modelers are superior.
So sorry, can I just ask a slight follow-up then?
Yes.
So from a public health perspective, we're often interested in trying to change the determinants of health that affect populations rather than individuals. So would that push us towards using a more of a microsimulation approach if we're interested in policy interventions?
Yeah.
Or do you think that's something that ABMs are equally kind of capable of kind of dealing with?
Yeah, I mean, it depends on what that particular example is. So if you need to know what the influence of individual interactions are, and behaviors, in particular, what behaviors are, but how behaviors can modify due to, say, influence of people around them, the environment, then you need an agent-based modeling approach. I think they both have brilliant utility. One of the problems of agent-based modeling is the computational and data requirements that you need for them and how you can scale them up. So it's not really an answer. I think it really is, what's your research question and what are the really important parts of that system that you need to capture? If you really want behavior and interactions, you wouldn't use microsimulation and vice versa. So I think at the beginning of any of these problems, conceptualizing them, that the first question is, what's the most appropriate method? ABMs are really easy to do as simple ones, as are microsimulation, but there's a whole raft of other methodologies out there that might be more appropriate.
Yeah. It sounds like you're not sort of set always on one method.
No.
Which is the most relevant, is most suitable?
No, but within the individual-based modeling community, there kind of is a bit of rivalry banter between microsimulation and agent-based modeling. We both think we're better. Obviously, agent-based models are better.
Yeah. I'm going to, Kirsten, you've got your hand raised. I'll just allow you to talk as well.
Thanks, Jonathan. Hi, Alison. Thank
Hi.
you. That was really, really interesting. I just wanted to maybe defend the animation at the beginning, because there's a junction in the heart of Addis Ababa that looks exactly like that. And people really don't crash into each other. It's remarkable how people actually move around each other. So, there are places where that actually reflects real life.
Yeah.
I wanted to ask, just that we've got lots of great qualitative researchers in the unit, and just thinking about what you were saying earlier about how difficult it is to get the how and the why of people's behaviour and movement in time and space. I just wondered if you have used qualitative research much to support models, and what role you see for it in general.
Yeah, I mean, the short answer is nowhere near as much as I should do. I mean, the area that I was working in before, that we had so much quantitative data that really we hadn't got to a point where we started asking, those why questions. I'm incredibly interested. I'd be really excited to talk about the types of qualitative data, because the behavior, how, the most accurate way to know how an individual is going to behave is not through analyzing different data sets, it's going and asking them. And often, sort of modelers, we sort of get a bit too, lots of big data, and play around with that and analyze it, where in fact, the qualitative data can really strengthen the models. Across the whole board of the process, from sort of forming those rules through to the validation aspects. Have we used it much? No. And there was a movement in Leeds for big qualitative data, these huge data sets, with interview type data, but I think one of the challenges there is taking qualitative data and sort of extracting what's important and putting it into a way that, your computational model can understand as well, without losing the sort of richness within that. So yeah, I think any work that I do within the unit, within these methods, has to have the qualitative data involved. It's half the story, isn't it? There's so much you can get from the lovely big spreadsheets, but obviously not me talking to people. You don't want me talking to the general public, but sort of that expertise in those sort of data sets, I would love to play around with and understand what's available more so.
Sounds great. You can't see me, but I'm smiling and nodding, and I look forward to talking more about it.
Fantastic.
Brilliant. Okay, we're probably near the end. So I had a question. I noticed in the talk that you said that the ABMs aren't fully utilized in health research. I wondered how you think they could be fully utilized.
Yeah, I mean, okay, this is going to show off all my ignorance and that I'm not a health person. Obviously, by Christmas, I'll be amazing at this. But from my limited understanding, and coming from the outside perspective, it seems that a health system is the same as an urban system. You've got processes that are important, that are connected to, it's a complex system. You've got lots of different variables, processes, all interrelated, all connected. There are cause and effects. One factor will affect population in many different ways. That, to my mind, the core elements of work I've been doing with individuals in an urban setting is the same. How can it be used here? I mean, you can test out sort of relationships between, I know Vital's doing work with microsimulation on mental health. That's one way you can use these types of models, but there's also the approach that we're taking over in Cypher as well, where we're looking at different effects of inclusive economy, et cetera, You can build these models, you can understand people's behaviors, and perhaps, one of the things, it sounds a bit Big Brother, but you can look at how can you change people's behaviors, positive interventions, stop people drinking, dying earlier in Glasgow, taking more exercise. How can you use these models to sort of promote and nudge these types of healthy behaviours? I mean, I could be wrong. There could be a whole slew of ABMs that are being used in health that I haven't come across, but from sort of cursory look at the literature, it seems to be around active travel. It seems to have quite a model, and a few ones on diabetes as well. But that's something that I admit I'm kind of an amateur there, and I'm going to have to learn about more so. But from a high level perspective, there seems to be such a crossover in what health modelling needs and what I've done, that there's a huge and ignoring COVID modelling, agent-based modelling, just ignore that. I think there's a huge amount of synergies that we can create, and a lot of fantastic work that we can do.
It sounds like there's loads of amazing opportunities in this field.
I hope so.
Yeah, we're just coming up to 1 o'clock now, so we'll draw to a close. But Alison, thank you very much. That was a really interesting overview, and thanks.
And hello to everybody. Hopefully, I'll meet you all in person at some point.
Yeah, I think people are starting to go back into the office. So whoever's in Wednesday, I'm sure will take you up on your offer, and maybe there's a great outside space where you can have a chat and lunch or whatever.
Talking to people in person would be amazing.
Yeah, I know, it's really nice. But yeah, thank you, Alison, and I look forward to meeting you in the future. Thanks from everyone who was here. I'm sure it's looking forward to meeting you.
Thanks for the invite. Thank you very much. Bye,
See you
everyone.
soon. Bye.
Bye.